What's up? Welcome to Quicker Calc. I make these videos for AP Calc AB/BC curriculum, but they can also apply to any college level calculus course. You've learned power rule, chain rule, and all this other stuff, but there's one last thing to add to your derivative taking repertoire. We got to be able to find the equation for the derivative of equations like this, which is pretty easy once we add some context to things that we've already been doing. In case you haven't seen all of these are the different notations to describe that we have turned a function into its derivative. This last one is particularly important and begs the question, what is this? Why is there dy over dx? Well, we've actually been doing that the whole time with every variable. When we take a derivative, we have to take it with respect to a certain variable. So in previous problems, we've been taking the derivative of y with respect to x, just denoting that that's the derivative function, and taking the derivative of x with respect to x just cancels it out. This actually highlights just how important chain rule is. We're going to use power rule to solve for the derivative of the outer function, keeping the inner function, x, and then multiply by the derivative of the inner function. Chain rule is actually everywhere. So we know that the derivative of y with respect to x is going to be dy over dx, aka y prime, but what about y squared? Well, all we have to do is chain rule it. We end up with 2y multiplied by dy over dx, but let's make this cuter, more digestible, and write it down as 2y y prime. You're likely to be given an equation like this and be asked to find y prime, so let's start by just breaking everything down and differentiating with respect to x. Perfect. So now we have this equation, but it isn't quite what we're being asked for since we have multiple y primes. From here, we just manipulate the equation with algebra. Put y prime on both sides, factor it out, and then divide the parentheses to isolate y prime, and there's our answer. I'd like you to try and solve this using product rule and implicit differentiation, so just pause the video real quick and then I'll run through it. Alright, so we'll write down exactly what we get from using product rule and then use algebra to get our y prime, substituting in pi over x for y. This question is about as hard as it gets, but fortunately I've gone over everything we need for the first part. We'll be finding y prime before we worry about the equation of the tangent line. Pause the video and try to solve it, then I'll have the breakdown. There is so much room for algebraic error here, so I'd start with writing down everything differentiated as it is before rearranging. Then I'd go ahead and carefully put together the equation for y prime. For the equation of the tangent slope line, we'll be plugging in the x and y values given to us into y prime, since that is where the instantaneous rate of change is occurring, and the slope for the tangent line at that point is going to be. So now we know the slope of the line is negative 1 over 3. All we have to do is plug the x and y coordinates into our point-slope form equation, and we can leave it like that or rewrite it into slope-intercept form. I got one more practice problem left for you to do, and then I'll have the steps and answers written down. Thank you so much for watching, and congrats, you should be able to solve any kind of derivative now. I appreciate it if you would give it a like and a subscribe. Have a great day.